चल.
Hi students, I am Pankaj Goyal. On behalf of my Impulse group, I have uploaded the solution for the particular query which I have got. I am reading the question is, this is a generator which is connected to a line and the terminal voltage is given here 1 per unit and the terminal voltage across this generator is given as 1 per unit. Now we need to find out that the steady state condition, what will be the maximum power flows from generator to this particular end. Okay, so I will tell you two methods by which we can solve this. This is basically the power which is flowing from this end to this end, and this is given by Eg into V divided by x1 plus x2 sine of delta minus 0. Here x1 is the reactance of this generator and x2 is reactant of this line, and delta minus 0, delta is the torque angle of this particular voltage and 0 angle is the at this bus. So for maximum power, what should be the value of delta? We are considering here that delta, if delta is 90 degree, then the power flow from this end to this end will be maximum. So the maximum value at delta equals to 90 degree is given by P max equals to Eg divided by 1.6. Here 1 per unit is the reactance of this generator and 0.6 per unit the reactance of this particular line. Now first method is what? We will calculate first the value of this current. We know the voltage at this end, and reactance between these two particular voltage. So we can find out the current which is flowing from this end to this end is what? Vt minus V divided by this particular reactance is this. So now we know the current, the same current I will flow from here. So we can write here what will the value of this Eg. Eg can be written as here. This is 1 at the angle of 0 degree. We are taking this voltage as a reference plus the whole reactance. This is 1 per unit and this is 0.6 per unit. Solving this, we'll get this, and we'll get, after solving this delta naught, we'll get this. Now we have given here maximum power flow delta should be 90 degree, and for this term should be 0 because this Eg will be at 90 degree, so only J term will be there. So this term should be 0. By equating this equals to 0, we'll get delta naught equals to 51.3 degree. In the second method, what we have calculated here, whatever the power flow from this A end to B should be same as the power flow between this A end to C. So if we put formula here, from this is the power flow from A to B, this should be equals to power flow from A to C. So here this voltage and this voltage divided by this reactance and the angle between them, sine of angle between them, and for this A to C we'll calculate here this voltage, reactance between them and the angle of these two. So by equating this Eg term will be cancelled out and this delta is 90 degree, so we'll get finally here delta naught equals to 51.3. By putting this delta naught value here in this equation, we will get Eg, this must be equals to this one. So we'll calculate the value of this Eg. This must be equals to 2.67 into sine of this angle. This must be equals to this. And by putting the value here in this equation, we'll get the P maximum, which actually flows from this particular point A to C. This is actually 2.083 divided by 1.6. This is equals to 1.3 per unit. This is actually the answer. Thank you.